Today we embark on a journey to unravel one of the most perplexing mysteries of the cosmos, Oumuamua. Imagine this. October 2017, astronomers spot an object unlike anything they've seen before, an elongated shape hurtling through our solar system, not bound by our sun's gravity. But here's the twist. It doesn't behave like any known asteroid or comet. Immediately, the scientific community was abuzz. Could this be an alien spacecraft, a piece of interstellar debris, or perhaps something far beyond our current understanding? In this video, we're diving deep into the mysteries and the mind-blowing theories surrounding Oumuamua, dissecting everything from its peculiar trajectory to its possible origins. But here's what's going to keep you hooked. By the end of this video, you'll understand why this strange object is such a groundbreaking discovery, sparking debates about extraterrestrial life and redefining how we see our place in the universe. So, if you've ever pondered the existence of alien civilizations or questioned what might lie beyond the boundaries of our known cosmos, you won't want to miss this. Stay tuned, because what you're about to learn will change how you think about the universe. If you're as captivated by the unknown as we are, don't forget to like this video and subscribe to the channel, Exploring the Universe. There's so much more to discover, and you won't want to miss what's next. In October 2017, finera commande reviews nyari. Ifraver din sefrinzis rumbarikan. Seori mi fari your and vichis garabifis. Astronomers made a discovery that would leave the scientific world buzzing with intrigue and speculation. For the first time in history, an object from outside our solar system was detected passing through. This mysterious traveler was named Oumuamua, which means scout or messenger from afar, arriving first in Hawaiian. The name was fitting, as Oumuamua became the first known interstellar object to visit our solar system. Its arrival marked a milestone in the field of astronomy, opening up a whole new realm of possibilities for the types of cosmic objects that could enter our space. But it wasn't just its origin that left scientists scratching their heads. Oumuamua's peculiar characteristics, its highly unusual trajectory and unexpected acceleration, sparked debates and even raised the question, could this be an artifact from an extraterrestrial civilization? As it passed through our solar system at breakneck speed, astronomers struggled to classify it. Was it a comet, an asteroid, or something entirely new? Unlike anything observed before, Oumuamua didn't display the typical behaviors of either. No visible tail like a comet, no regular orbit like an asteroid. This led to a whirlwind of theories and an enduring mystery that remains unsolved to this day. What made Oumuamua especially baffling was not just its speed, but also its lack of a clear explanation for how it was moving. The fact that this was the first interstellar object ever detected made its discovery truly groundbreaking. Its mere presence hinted at the vast number of objects drifting through the galaxy they see far beyond our previous understanding. Yet what truly puzzled the scientific community was its form and motion. Far removed from anything we had ever seen, what could cause such an object to behave so unpredictably? The hunt for answers had begun, and with it, a wave of fascination about what other mysteries the universe might have in store for us. One of the first things that made Oumuamua stand out from anything we've ever encountered was its bizarre, elongated shape. Like most comets or asteroids, which tend to be more rounded or irregularly shaped, Oumuamua was long and thin, stretching roughly 400 meters in length, but only about 40 meters wide. Imagine a massive space cigar floating through the cosmos. This strange shape alone sparked immediate curiosity among scientists, as such proportions are rarely seen in natural objects within our solar system. Typically, asteroids and comets are formed by gravitational forces that shape them into more spherical or irregular masses. So, how did Oumuamua end up with such a distinct elongated form? Adding to the mystery was its movement. Not only was Oumuamua traveling at incredible speeds, clocking in at over 300,000 kilometers per hour, but its trajectory was hyperbolic. This means it wasn't orbiting the sun like objects native to our solar system do. Instead, it appeared to be just passing through, a visitor from some far-off region of the galaxy, never to return. Such a path clearly indicated its interstellar origin. And yet, the more scientists observed, the more questions arose. Unlike a typical comet, Oumuamua didn't exhibit a tail of gas and dust, which comets usually produce when they get close to the sun. Moreover, its motion showed an odd acceleration that couldn't be fully explained by gravitational forces alone. This combination of its unusual shape, speed, and unexplained acceleration led to a flood of speculation. Was it a fragment of some larger object torn apart by gravitational forces in its home system? Could it be a piece of debris from a massive collision in a distant galaxy? Or, as some theorized, could it be something more artificial, a probe or spacecraft sent by another civilization? The scientific community was left grappling with these questions as Oumuamua's behavior and physical properties defied easy explanation. The enigma deepened, and with it, the fascination surrounding this unprecedented cosmic visitor. Among the many questions surrounding Oumuamua, one of the boldest and most controversial theories came from Harvard astrophysicist Avi Loeb. Loeb suggested that Oumuamua might not be a natural object at all, but rather an interstellar spacecraft or a piece of alien technology. This theory quickly captured public attention and sparked widespread debate. Loeb's argument hinged on one particularly puzzling observation: Oumuamua's unexplained acceleration. As it moved through our solar system, it appeared to speed up without the typical release of gas or dust that we would expect from a comet experiencing outgassing. This led Loeb to hypothesize that Oumuamua could be propelled by something much more advanced, possibly a light sail, a theoretical technology that harnesses radiation from stars to push an object through space. The idea of our course, being an artificial craft was certainly captivating, raising the possibility of it being a probe sent by an advanced alien civilization. A light sail would explain its sudden acceleration, as sunlight could push such a structure through space without the need for traditional fuel or propellant. Loeb pointed to the object's thin, elongated shape as further evidence, suggesting that it could be a defunct piece of technology drifting through space for thousands, if not millions, of years. However, while Loeb's theory grabbed headlines and piqued the interest of the public, many in the scientific community leaned toward more conventional explanations. Skeptics argued that Oumuamua's behavior could still be explained by natural processes, even if they didn't follow the usual patterns. Some proposed that Oumuamua was a fragment of a larger object, perhaps a comet or asteroid, that had been torn apart by gravitational forces in its home system. Others suggested that the object could be composed of materials that behave differently under solar radiation, allowing for its odd acceleration without the release of visible gases. While Loeb's alien spacecraft theory remains a tantalizing possibility, most scientists continue to explore natural explanations, recognizing that our understanding of interstellar objects is still in its infancy. The debate over Oumuamua is far from settled, but one thing is clear: its arrival has forced astronomers to rethink long-held assumptions about what's out there beyond the bounds of our solar system. Whether natural or artificial, Oumuamua has opened a new chapter in our exploration of the cosmos, reminding us of just how much we have yet to learn. One of the biggest controversies surrounding Oumuamua was its unexplained non-gravitational acceleration. In simple terms, this means that in addition to being pulled by the gravitational forces of the sun and planets, something else was pushing Oumuamua as it sped through our solar system. Normally, this kind of behavior is seen in comets, which release gases and dust as they approach the sun, creating a visible tail and providing a thrust that changes their speed. However, Oumuamua exhibited no visible signs of outgassing. No tail, no debris, nothing that would explain why it suddenly accelerated. This left scientists puzzled, as the object wasn't behaving like any comet or asteroid we had ever encountered. The lack of visible gas ejections led to numerous theories. Some scientists proposed that Oumuamua could be made of an entirely different material than what we typically observe in space. For instance, it might be composed of a lightweight structure or have a surface covered in volatile materials that quickly vaporized as it neared the sun, but without leaving a detectable trail. Others suggested that Oumuamua might have a very thin layer of frozen hydrogen or nitrogen ice, which could have sublimated, turned directly from solid to gas when exposed to the sun's heat, creating the acceleration without visible emissions. This unexplained acceleration gave rise to debates within the scientific community. Could it be that we are simply dealing with a new type of object, one that defies the classifications we've been using for centuries? Or was there something even more extraordinary at play, such as a new, unknown force or material that only appears in interstellar objects? Some went as far as to suggest that Oumuamua's motion might have been artificially influenced, lending credence to the idea that it could be a piece of alien technology. Despite these compelling hypotheses, to this day, there is no definitive explanation for Oumuamua's strange behavior. The object exited our solar system before we could gather more data, leaving many of these questions unanswered. The mystery of its acceleration remains one of the most intriguing aspects of its journey, sparking further debate and research. While some scientists lean towards natural explanations, such as the presence of exotic ices or dust, others continue to explore the more unconventional possibilities. Whatever the case, Oumuamua has challenged the limits of our understanding of the cosmos, proving that there's still so much left to discover in the vastness of space. One of the more fascinating possibilities that captivated scientists was the idea that Oumuamua might have originated not just from another star system, but potentially from another galaxy altogether. If true, this would make it not only a rare visitor to our solar system, but a one-of-a-kind opportunity to study an object that was formed under entirely different conditions than anything we've observed. The thought that Oumuamua could be a relic from a distant galaxy opens the door to many intriguing questions. What can this mysterious object teach us about the formation of planets and stars outside our familiar universe? What kind of forces shaped it? And what other cosmic phenomena might have contributed to its strange journey across intergalactic space? While these questions are difficult to answer given the brief time Oumuamua spent within our reach, the mere possibility that we might have observed something from such a distant origin is thrilling. If Oumuamua did indeed come from another galaxy, it would be the first time in human history that we've had the chance to study material from beyond the Milky Way. This idea stirs the imagination. What if Oumuamua has been traveling through space for millions, perhaps billions of years, carrying within it clues about the earliest epochs of the universe? Though we may never know the exact origin of Oumuamua, the fact that it behaves so differently from anything we've seen before suggests that there's still much to learn about the types of objects that inhabit the galaxy and possibly beyond. If it provide indirect evidence of how common or rare interstellar travel for objects like this might be, how many other messengers like Oumuamua could be floating between the stars, waiting to cross paths with another solar system? Even though Oumuamua has long since left our solar system, its legacy endures, pushing scientists to think bigger and bolder about the possibilities of what exists beyond our galactic neighborhood. The discovery of this enigmatic traveler has sparked discussions about future missions that could one day intercept similar objects and study them up close. Whether from our galaxy or another, Oumuamua serves as a reminder that the universe is far more complex and mysterious than we could have ever imagined, and that we are only at the beginning of our journey in understanding it. As the years have passed, the scientific community remains divided on what Oumuamua truly is. While some researchers are convinced that it might have been a gas-poor comet, others argue that it could be a fragment of a planet or even an asteroid ejected from its home system long ago. But then there's a third camp of scientists who believe that Oumuamua might represent something entirely new, an object unlike anything we've ever seen before. Could it be that this enigmatic traveler doesn't fit neatly into any of our existing categories? And if so, what does that mean for our understanding of the universe? The Comet hypothesis suggests that Oumuamua was made of volatile materials that sublimated as it approached the sun, causing the unexplained acceleration without the visible signs of gas ejection. But the lack of a typical cometary tail, along with the absence of any detectable gas, leaves this theory with significant gaps. On the other hand, those favoring the asteroid theory argue that it could be a rocky fragment, perhaps torn from a larger body by some cosmic event, such as a collision or a supernova. But again, Oumuamua's strange shape and unexpected acceleration challenge this explanation as well. A growing number of scientists now propose that Oumuamua may belong to a new class of interstellar objects, something that defies the binary distinction between comets and asteroids. This something new theory suggests that there could be countless objects like Oumuamua drifting through space, and that this is just the first we've encountered. Some have speculated that it could be an object made of materials we have yet to observe, or that it formed under conditions that we do not yet understand. If this is the case, Oumuamua could be a key to unlocking a whole new area of astrophysics. One thing is clear, left us with more questions than answers. Its fleeting visit to our solar system, coupled with its puzzling characteristics, ensured that it will remain a subject of study and speculation for generations to come. Whether it's classified as a comet, an asteroid, or something entirely different, Oumuamua has already expanded our understanding of the types of objects that may exist in the universe. It serves as a reminder that, despite our advances in technology and science, there are still mysteries in the cosmos that we are just beginning to uncover. The debate over Oumuamua is far from over, and its discovery has likely paved the way for future research on interstellar objects, opening the door to a new era of exploration and discovery. Regardless of what Oumuamua truly is, its discovery has shifted our perspective on the universe and what may lie beyond our familiar boundaries. Oumuamua proved that interstellar objects can and do pass through our solar system, expanding our understanding of the types of celestial phenomena we might encounter. This realization opens up exciting possibilities for future discoveries. What other kinds of objects are drifting through the vastness of space, waiting to be observed? Could some of these objects carry traces of extraterrestrial life or technology from distant civilizations? While these ideas may seem speculative, Oumuamua has forced us to think more deeply about the broader universe and what it could hold. Its brief but mysterious visit has also sparked a wave of interest in developing new technologies and methods to detect and study similar interstellar objects in the future. Currently, our detection systems are largely designed to observe objects within our solar system, but Oumuamua's appearance made it clear that we need to expand our capabilities to identify these rare visitors earlier and study them more thoroughly. The challenge lies in their speed and unpredictability, but advancements in telescopes, space missions, and artificial intelligence could help us catch the next interstellar traveler before it speeds away. On a broader scale, Oumuamua taught us a valuable lesson. The universe is still full of unknowns. Despite our advances in astronomy, there is still so much we have yet to learn, and objects like Oumuamua are a reminder of just how little we truly understand. Its passage served as a wake-up call for the scientific community, reminding us that we are only scratching the surface of what lies beyond. More than just a strange object in the sky, Warpuri on Oumuamua symbolizes the boundless mysteries of the cosmos, motivating researchers to keep exploring, questioning, and pushing the boundaries of what we know. As our understanding of the universe continues to evolve, Oumuamua will likely be remembered as a turning point in how we think about interstellar exploration. It has paved the way for future studies on objects from beyond our solar system, and perhaps one day the technology we develop will allow us to uncover more of the secrets that the universe still holds. Whether or not we ever fully understand Oumuamua itself, its legacy will inspire generations of scientists to keep asking the biggest questions about the cosmos. Oumuamua was a mysterious traveler that crossed our path and left behind a trail of wonder and fascination. Whether it was a comet, an asteroid, or even an alien spacecraft, its brief visit reminded us of the vastness of the universe and the countless mysteries waiting to be unraveled. In the grand scheme of things, Oumuamua is just one of the many enigmas that space holds, yet its presence sparked a global conversation that continues to fuel our curiosity. What it truly was may remain unknown, but its significance lies in how it expanded our imagination and inspired a new era of exploration. As we close this chapter on Oumuamua, one thing remains certain: the universe is full of surprises, and we're just beginning to scratch the surface. Perhaps the most important lesson Oumuamua taught us is that our understanding of space is far from complete. The unknown is not something to fear, but something to embrace, for it drives us to seek answers and pushes the boundaries of what we thought was possible. If you're as fascinated as I am by this journey into the unknown, make sure to stay tuned for more cosmic adventures. There's so much more to discover out there, and who knows what the next mystery will be. Yo,